2023 question 8 is a projectiles question. P and Q projected into the air from the points A and B. Distance D. All the rest we know. Time 0 we have for A and time 1 for B. No initial velocity, but we have the angles. We're told that they collide in midair when t is 3. Let's say that's here. They collide at this point. So we can say that the displacement in the j direction will be equal for the collision. Show that u is 28 to the nearest whole number. Okay, well let's look at the initial velocities of these projectiles. The velocity of p, u cos alpha in the I direction, 38 cos 41 in the I, plus 38 sine 41 in the j. The velocity of q is negative in the I, minus u cos 64 in the I, plus u sine 64 in the j. So for the displacement to be equal, the displacement of p is equal to, in the j direction, now we're looking at the displacement in the j direction, ut plus a half at squared. So it's going to be 38 sine 41 by 3, and a half a is minus 4.9 by t squared. Displacement in the q direction will be u sine 64, it's in the air for 2 seconds, minus 4.9 by 4. So if these are equal to each other, let's write that out. 38 sine 41, well, 38 by 3 is 114 sine 41 minus 44.1 is equal to 2u sine 64 minus 19.6. So if we isolate u, we get 114 sine 41 minus 44.1 plus 19.6 divided by 2 sine 64. We'll leave u on its own. And this is equal to, on a calculator, 27.976, 27.98 meters per second. Then we're asked to show that it's 28 to the nearest whole number, so we have that equals 28. Part 2, we're asked to calculate d. So that's in the I, the displacement in the I direction, so we want to get a to here, and it's going to be obviously the same information as before. So we want displacement in the I direction, so the distance traveled in the I direction for p is going to be just ut, no a, no acceleration. So that's going to be the I direction 38 cos 41 times 3, so just a 114 cos 41, 114 cos 41. And for q, which we'll have to add to it, we're going to have, what do we have, 28 we have 28 cos 64. We can't have negative, so 28 cos 64, and I've just messing around here a little bit, but I put time in here. That is going to be times 2, so 114 cos 41 plus 56 cos 64 is going to be the distance between the 2 points A and B, which is going to be D. And the 2 individual answers are 86.04. This is using 28. If we use 27.98, we get a slightly different answer. This is going to be 110.59 with 27.98. I think you get 110.57. I'll just double check that. You do. On to part 3, which is in terms of I and j, calculate the velocity of p, velocity of q when the balls collide. So we want the velocities when t is equal to 3. Okay, so let's just go back up and get our information. So the velocity of p, so velocity is u plus at. We got to do it in the I direction with no acceleration, and in the j direction with a. So the velocity of p in terms of I and j is just u in the I direction and u plus at in the j direction. So just be careful with this one. So u in the I direction, we got 38 cos 41, I think 28.68. I'll write it out, 38 cos 41 in the I, plus we had 38 sine 41 minus 9.8 acceleration for the 3 seconds it was in the air. So the I stays the same and the j is slowing down. So this works out to be, to 2 decimals, 28.68 in the I direction, and it's minus 4.469, 4.47, 4.47 in the j direction. So that's the velocity of p in terms of I and j. What about q? The velocity of q is going to be my u. So we had, I'll take 27.98 minus 27.98 cos of 64 in the I. And then we're going to have plus minus, no, it's positive u for j, 27 sine 64 minus 9.8 by 2 plus ut, 2 seconds in the air. So minus 9.8 by 2 in the j direction. First part gives minus 12.27 in the I, and then in the j direction it gives plus 5.54855 in the j direction. Yes, I didn't leave out the 0.98. So this is my velocity of p and velocity of q. Now it goes on to dot product. So for dot product, they have it here, time is equal to 3. The dot product of the velocities, velocity of p by the velocity of q. What we do here is we multiply the I components. So we have 28.68 times minus 12.27 in the I direction. I think I have an extra bracket there in the I. And then we're going to have plus in the j direction minus 4.47 by 5.55 minus 4.47 by 5.55 in the j. So this dot product, which leads on to the last part of p and q, is equal to, we don't need the I and the j, this is going to give minus 376.71, leading to the last part, which is hence or otherwise calculate the acute angle between these lines. Now what we need to know here is the magnitude of the velocity of p times the magnitude of the velocity of q by the cos of the angle between them is equal to the velocity of p by the velocity of q, the dot product that we've just done, which we got minus 376.714. Now, magnitude of p, what do we have here for p? We have the square root of 28.68 squared plus 4.47 squared. That's going to give 29.03. So that's 29.03 times q by the cos of theta. So the magnitude, the velocity of q, magnitude of the velocity of p, keep leaving out my arrows, q, p and q. Where's my q? It's p, q is up above here. The square root of 12.27 squared plus 5.55 squared is going to give 13.47 for me. So 13.47. So if I divide by those two, I'll get the cos of theta is equal to minus 0. This is dividing 376 by the other two, 9633, meaning that theta is the inverse of the other side. 15.56 degrees is what my calculator is telling me for the end of question 8.